Hello everyone, welcome to Nature by Design. So in today's tutorial, we're going to walk through QGIS. So QGIS is a free and open source geographic information system. You can use that for creating, editing, visualizing and analyzing geospatial data. It's going to help you put together a really basic site analysis using the data sets you're going to find online. In this video, you're going to learn the basics to get started, including how to install QGIS, how to load data, and how to create your first map. The first thing is to download QGIS. We're going to head over to qgis.org, click on download here on the top, and skip it, go to download, and when you scroll down, you can choose the installer appropriate for your operating system. It can be Windows, Mac OS, or Linux. QGIS is also free to access in the CAT lab at uni. Feel free to use the CAT lab to practice that. And then you just follow the installation steps. It's very straightforward. And once it's complete, we can open the application. So now our software is loaded. Let's create a new empty map, new empty project from here. And you may notice the code here, EPSG 4326. This is called a coordinates reference, which you can also see in the bottom right corner here, right next to the little globe icon. So the layers we're going to work with in QGIS ought to have the same coordinate system to make sure they appear in the right place and align with each other. So CRS has that function. We'll open a new empty project now and we can take a closer look at it. So now we can click on this little icon here and you can see the list of the coordinates we will want to work with in this project, because we're working in a really specific region in South Australia. So we're going to choose GDA 2020. The code will be 7854. And you can see the preview here is targeting a really specific band of region in Australia. So we click on apply and OK. So now see the CRS is changed to our ideal coordinate. Let's take a look at the interface. So on the left-hand side, you can see the browser panel, which is showing all the layers or catalogs of layers you're going to use to create your maps. Right under it, you have the layer panel, where you're going to drop all your layers here. And on the right-hand side, we have the processing toolbox. And if it's not showing up in your interface, you can click on processing and make sure you tick toolbox and it's going to appear now. So let's explore this little button here. This is the add layers button. Basically, what the data set you find, you can load them using this button here. QGIS is supporting the views of the vector layers, which always comes in shape file or GeoJSON file. Raster layers, which you can see a lot of formats as TIF, like .TIF. So it's always DM file, which is the digital elevation model. And you can also load point cloud, which is based on a LiDAR dataset. Before we step into exploring all the website that we're going to grab those data, we're going to give us a really general basic map to work with and locate our site. And we can go to web, quick map services, and we click on these OpenStreetMap service, OSM standard, and now we can see a really simple map covering the whole world. Now we can zoom into Australia, South Australia, and the site we're going to find is around the Port Stanback, which is a really heavily industrial site, but it's also surrounded by like some linear parks, some creeks, and some conservations, which will be really interesting. So now we have the basic map. We can change the style by clicking the OS standards layer that we just created here in the layer panel. For example, we can change transparency. Let's change that to 50%, and probably desaturated. And let's click apply and OK. So this just gives us a really clean base, which is more muted. So our actual working layers can stand a bit out on top of it. Now you might have the question where to get data. Here are 3 really useful and basic websites you can use to collect those data sets, no matter that's a vector file or a raster file or even point cloud. So the first one is Data.sa. It has the search panel here. You can just type in whatever keywords that you want to look into. So let's try watercourse. It will just show 60 data sets found on this website. It's all about watercourse. We have prescribed watercourse in Australia. This one looks great, and you can also, let's step back, you can also see supported file types on the bottom of it. So if it has your ideal file type, you can click into it. And now I want to download a shapefile, which is a vector. I'm going to click explore and go to resource, and the download is going to automatically start. While it's downloading, let's try another keyword. So I want to look into industrial land, because our site is heavily industrial, right? This one has the shapefile as well, which is the SHP. So we're going to open that as well. And I find the SHP and go to this resource and just start downloading it. Once they're all downloaded, we can go to our downloads folder. So once they're all downloaded, we can go to our download folder and see they're both coming in zip files. So after we unzip them, we can open the folder and have a look. We can see the shape files that we want here. So we'll go back to Qgis, click on add layers again, and click on just 3 dots and find our file. So we try industrial land first. Oops. So now you see I choose the wrong catalog, and we want to go to the right one, which is the vector for shapefile. And click on the 3 dots again. Go to desktop, industrial land. And click add. And close it. So we have all the industrial land use area colored in green. And now let's try the watercourse. And also let's just try drag this shapefile directly to the layer panel. And click OK. And now you can see those fine green lines representing water flow and waterway surrounding our target area. So these are all the basic information and basic graphics, and I'm going to show you how to adjust the graphics to make them look more professional later. But before that, let's jump into the second website, which is National Map. So on this website, you can choose your location. So our site will be Port Stanlac. Should show up here, and click on the location. So it just brings us all the way to our site. And now if you click on Explore Data, it will just give you a long catalog of different types of data. So you can search the keywords here. Let's have a look at something about traffic. For example, rail network. So it has the statewide rail network, and we click on this data, and it provides us a preview here. So once we confirm it's covering our site in the preview, we're going to confirm that data is kind of helpful to our research. So we add it to the map, and now you can see those red lines standing for the railway network. And we can also go to About Data and scroll down, click on Export Data. So this is going to download the data as a vector file as well. Let's click done. And another way to search for data is scroll to the very bottom of the catalog and you can find SA government data, and we click on state data and just scroll down, and you kind of just categorize all the data in a more specific department. So for example, we want to look into something about environment and water. We can click on, can have a look at surface water catchment. And let's add that to the map. So it just shows what a catchment area divided by those white lines. We can also try, let's say, conservation boundary. Add to map. Now we have those little pockets of conservation boundary. It can be quite confusing. Let's make this invisible. So we have the parcels reservation area. This can be quite helpful to your research. We click on about data and scroll to the bottom, export data. So now we have some data about water and traffic and also land use. We can go back to Qgis now and just keep exporting the data we found. We have these GeoJSON data, which is also, so if we click on vector and click on those 3 dots again, and we can find the GeoJSON data is also included in the vector category. So we can choose GeoJSON data and go to where we download the data, which is in download, and click on conservation reserve and open it. Add. So this data might include a lot of polygons, so it just takes more time to scan. After the scan is done, we click on Adelaide. And now we have these beige colored pockets representing the conservation reserves around our site. Let's keep exporting, say, rail network. So it's also GeoJSON data. Let's just drag that in our menu. And you can see the pink line, which is the railway network. All right. With these example data, let's then look into how you can visualize them in a more professional way. So if we double click on data we just added, it'll make you change the layer property. So now if we click on a color, and probably we're going to choose a dark red color and make it wider, just more accentuated on the page, and click apply and click OK. Now the railway line is a dark red. You can keep exploring the visualization of the rest of the layers, but here I'm going to speed up. And after visualizing these elements we just imported to our base map, this map just looks more cleaner and easier to read. So now we're happy with the basic information on the map, and then we're going to step into the third website, which is Elvis, Elevation and Depth. This is a website that's going to help you collect the foundation spatial data, including data in point clouds formats and also DEM formats, which is the digital elevation models. So how it works is we can click on location search and go for Port Stanback. going to lead you right to the jetty, which is right next to our site, and then we click water data. So it's going to give you an option to draw a boundary in either box or circle or irregular polygon shape. So this boundary is going to cover what the area you want your data to cover. For example, we click draw, and I want to, of course, include our sites, but also the creeks on the north and south side, and also some residential areas on the east side. So I'm going to start from here to here. Now when you're happy with the boundary, you can click search. So the search results includes a lot of different formats of data. Digital elevation models, that's exactly what we want to explore right now. So this model is with 50 centimeter interval, which is going to be quite detailed in QGIS. It also gives us point cloud data and also digital elevation models in a bigger interval, which is going to be smoother and less accurate. Now I want to select the 50 centimeter interval digital elevation model, and we can pick our industry, and then you want to type in your email address. So all the search results are going to send to you your email in a bit as a zip file. So after a little bit, you're going to receive an email looking like this. It's from elevation.gov.au, and so your data is ready. It's going to send you a link of a zip file which includes all the data you require. So I'm going to go to download. Just click the file I just unzipped. In this folder, it just gives you all the DEM file. What we want to open is the DEM file, 50 centimeter one. And let's just try drop them all in our QGIS and see what happens. So how the TIFF file is working when we zoom into our file is probably you can see here. It's made up by millions of tiles. It's like your kitchen tiles on the wall. So each tile is of 50 centimeter dimension, which makes our data looks very detailed. We'll zoom out. So now you can see all the DEM files are separate. It's just a bit hard to manipulate and work with. So now we just want to merge all of them. To merge all of them, we go to raster, because this layer is a raster layer, and go to miscellaneous. And this has the command merge. I'll click on that. So it's going to allow you to select all your input layer and merge them. The other way to get a merge tool is to type in merge in the toolbox in the processing panel. So the command also appears here. So now we want to select water layers that we just imported. So toggle. We don't want this one. After selecting all of them, we hit run. We'll close that. So now we see a merged layer of the raster of the DEM. Now we can just make the rest of them invisible or just delete all the individual layers. So now with all the layers combined into one, it's just much easier to manipulate and change the graphic as a unity. But now the merged layer looks really musky and blurry, so it's not going to be really appealing shown our mapping. All we want to do is to search for hue shade. And hit run. We'll close that. So now it looks much better. You just show all the ridges and road, and also the industrial districts and residential area like in a much more clear way. We can now use this one as our base, so I'm going to drag it all the way to the bottom. You can also double click on hue shade and just change the brightness, reduce the brightness a little bit, and increase the contrast just to make all the ridges and roads standing out a little bit more and just make the map element look more clear. You can play with it. I just skip the process to speed up. And now with all the additional layers turned off, I'm going to show you another way to analyze the terrain by introduce aspect and slope based on the merged DEM model. So let's turn Hue Shader off for now and turn the merge layer back on. So if we type in aspects in our processing toolbox and just choose aspects under the raster terrain analysis, it's gonna let you select the elevation layer. So the layer we wanna add aspects on will be our merged DEM layer. So we're gonna choose the merge layer, and we can keep the Z factor to 1 without changing that. And save to a temporary file, and let's hit run. So if we close that now, you can see a new aspect layer has been generated, but it's underneath the merge layer, so we're going to bring that up. And now you can see the whole terrain is divided in black and white color. So the white color, or say the brighter color, will represent the terrain with steeper slopes, and the black color will just represent the negative side of it. So this will be a more dramatic way to show the direction where the ridges are facing and to analyze our terrain. And next option is to introduce the slope analysis. So it's also under the raster terrain analysis, and we find slope here, double click on that. And the same thing is what we want to analyze based on is the merged layer. And again, save that to a temporary file and hit run. And now we have a really subtle map representing all the slopes on the side. And you can also see from the sidebar, the slope will just vary from 1 to 88. So when you zoom in to a specific site, you can imply the slope according to the grey band here. And let's turn our merge layer off. So now we have different layers representing different elements to analyze the terrain for us. One option is to reduce the transparency of the slope. Let's see what it looks like. So now your slope map can cooperate with the aspect map underneath it. You can also turn on the hue shade map underneath it and just keep reducing the aspect transparency. Let's say, reduce that a little bit. So now we have a new base mapping showing all the aspects and slope. Now let's reduce the transparency of the slope to a little bit and click OK. And now let's turn on all the layers on the top of existing terrain analysis and move all the terrain models to the bottom. So now our map has more characters and more elements that's supportive to our further analysis. So finally, I'm going to show you how to export your map to scale and cover as much elements you want to cover for your future analysis. Let's go to Project on the very top of the interface and choose New Print Layout. And we can just name it, or we'll just call it Demo, Nature by Design, hit OK. And now it's going to lead you to another new interface. So you can see it gives us a blank canvas, and if we single click on it, you can see the page properties. So at the moment it's A4. For example, we want to export an A1 map, and let's keep it landscape. You don't have to change anything else in this property. And now let's add items here, add map. So it's all up to you. Just see if you want to leave a margin on the edge of the page. I'm going to leave a really small margin, and now you can see it's rendering a map here. And when you select this icon here, you are selecting your map page, which is the page size you just added, and you can change the scale here. At the moment, let's try 20,000. And normally the rendering process will take a long time. One trick that will help us speed up is to turn all the layer off, only leave your OSM layer on, just to just relieve some burden for your software. So it's basically just guiding you to the right location that you want your map to cover. And you can always click this refreshing button to refresh the rendering. And now the base map is loaded, we can also pan it by clicking this icon here. So this one is basically changing the position or the centering of the content we want to show on our map. So we just need to left click and hold and pan it through to the extent that you feel like it's okay to show all your content. And now we can go back and turn on our merged DM model. Let's go back to our layout. Now with the merge layer turned on, we can see the scale we just set is a bit too big. So I'm going to reduce that to 10,000 and reload that again. And now we can see 10,000 works much better for our working extent. And now let's click on this icon again and left click and hold and pan our map through to the left, just show the complete map. And now when our map extent's shown the ideal extent, we can go back to the main interface, like the work interface, and turn on all the layers on the top. And let's go back to our canvas and wait for it to refresh. So while we're adjusting our map elements, I also turn off our slope just to make the background less darker. I also go back to this icon here and just change our map extent. And now our map is properly placed on our canvas. And we can go to export PDF. And I'm going to call that demo nature by design 10,000. And save that to my desktop and hit save. And now when the export is finished, I'm going to go to my desktop and see our final result of map. So now our map is successfully exported. We can see all our layers, including conservation areas and the hatched industrial area, and also the watercourse waterway and also the railway network. And you may realize the watercourse line is really fainted, like really thin. And now you can go back to your Qgis interface, like the work interface, to thicken that furthermore, just to make that more prominent on the page. And now our map is successfully exported. You can see all the layers we want, including conservation areas, the hatched industrial areas, and the railway network were nicely laid out on the map. But as you can tell, the watercourse line is a bit fainted, like it's a bit too thin. So now you may want to go back to your Qgis interface to adjust the thickness and repeat all the process again and export again. Above is all the process of importing dataset and adjusting dataset, visualizing your map, and then exporting your final map outcome from QGIS. You're welcome to just do more practices on it. I hope you enjoy this video. So in the next video, we're going to explore how to generate a set of contour line to assist our site analysis using digital elevation model in QGIS. I'll see you in the next one.